Good morning, children. So today again we are going with another new chapter of the same subject, physics in science, that is light, reflection and refraction. So what do you mean by reflection and refraction? There is a lot of difference between the words reflection and refraction here. See, bending of light is called refraction and reflecting of light is called reflection. It travels in the air in velocity of 3 into 10 to the power of 8 meters per second. That is light, I told you. So how fast it travels? It travels in the air in the velocity of 3 into 10 to the power of 8 meters per second. So we have these things here. In light and reflection and refraction, during the day, the sunlight helps to see the objects. An object reflects. If you have the textbook, just go to it, you underline here. An object reflects the light that falls on it. The object reflects light that falls on it. This reflected light, when received by our eyes, enables us to see things. So when the light falls on the object, if that light is reflected to the eyes, and then only we can see the objects. So if you want to see the objects, we will put the light to the object but not to our eyes. Why we will not put the light to our eyes? Because eyes are the main things which you are seeing the objects there. But still what we are doing here, we are putting the light to the object. So when we put the light to the object, what happens here is the light reflects back and again, so that it can be seen cleanly or it can be seen easily. There are a number of common wonderful phenomena associated with light, such as image of formation by mirrors, the twinkling of stars, the beautiful colors of rainbow, bending of light by a medium, and so on. A study of the properties of light helps us to explore them. Let us see what are the properties of light here. So, for example, he has given some, according to mine, so the velocity of light in air is 3 into 10 to the power of 8 meters per second. Velocity of light in air, and it casts the shadow. Main thing is we have the shadow. It casts the shadow. Third one is light is reticular propagation. So it always travels in a straight line. So that is there. It always travels in a straight line. Light never travels in a zigzag motion. It always travels in a straight line. Light has a dual nature, means it has two types of nature. That is, we will see what it is there. So in this chapter, we will study the phenomena of reflection and refraction of light using the straight line propagation of light. These basic concepts will help us in the study of some of the optical phenomena in nature. We shall try to understand in this chapter the reflection of light by spherical mirrors. So we will take the spherical mirrors and we will see the mirrors. So what are spherical mirrors? I will tell you. So what are the spherical mirrors? So how many types of mirrors are there? That also will be going there. So first let us see reflection of light. So what do you mean by reflection of light? I told you also, reflection means nothing but bouncing of light. Generally we use the word bouncing of light. Reflection of light in the sense bouncing. Bouncing of light. Reflection means when it bounces back, then we call it as the reflection of the light. A highly polished surface such as mirror reflects most of the light falling on it. You are already familiar with the laws of light. I think you know the laws of light. First one is the angle of incidence is equal to the angle of reflection. The angle of incidence is equal to the angle of reflection. So in which angle it is incident, it is falling, it will be equal to the angle of reflection. In first law, which we studied in 8th and 9th standard also. Sorry. The angle of incidence is equal to the angle of reflection. The second law says the incident ray, the normal ray, and the point of incidence and reflected ray all lie in the same plane. So one thing you have to remember is the incident ray, the reflected ray, and the normal in the plane always lies in the same plane. One is the incident ray, second one is the normal, and third one is the point of incident and refracted. So all these three lies in the same plane. What is there? The incident ray, the laws of reflection what says the angle of incidence is equal to the angle of reflection, and the incident ray, the normal to the mirror at the point of incidence and reflected ray all lie in the same plane. So these laws of reflection are applicable to all types of reflecting surfaces, not only one type of surfaces. These are related to the all type of reflectors, plane mirrors. So what are the properties of these images? Let us see. So by plane mirror we will get two types of images. One is virtual and another one is erect. Virtual and erect types of images. The size of the image is equal to that of the object. The image formed is far behind the mirror as the object is in front of it. Further, the image laterally inverted. It is totally generally inverted. How do this image just be when the reflecting surfaces are curved? Let us explore. So let us go to the spherical mirrors. So we have the spherical mirrors here. So a reflecting surface of a spherical mirror may be curved inward or outward. Curved inward or outward means it may be curved inward or it may be curved outward. Like this it may be. You may have either like this or like this. It may be curved inward or it may be curved outward. A spherical mirror whose reflecting surface is curved outward is called convex mirror. So if it is inverted towards the center of the sphere is called concave mirror. First thing is a spherical mirror whose reflecting surface is curved inwards, that is faces toward the center of the sphere is called concave. A spherical mirror whose reflection surface is curved outwards is called convex. The systematic representation of the mirrors is shown in the figure. So generally speaking, so we use these type of places here. One is convex, another one is concave. So two types of, one is we call as emerging, means dispersing and emerging, we use the words there. Two types of mirrors are given here. You may now understand the surface of the spoon curved inwards can be approximated to a concave mirror. The surface of the spoon verged outward can be approximated as convex mirror. So the best example is given is spoon. If you take this is a spoon, so if you take inside the spoon concave, so outside the spoon it will be convex. So two types here. If it is inside, it is concave. It is outside, you call it as convex mirrors. Two types of mirrors generally we will be having here. Another thing is the reflecting surface of a spherical mirror forms a part of sphere. This sphere has a center. So these spheres will have the center here. And this center is called C. And we have radius of curvature. I think these we have studied already. The radius of the sphere of which the curvature of the mirror, it is represented by the letter R. You may note that the distance PC is equal to the radius of the curvature. Imagine a straight line passing through the pole of the center of curvature of a spherical mirror. This line is called spherical axis. So or in called generally we use the word principal axis also in the mirror. Remember that the principal axis is normal to the mirror at the pole. When you take at the pole, it is always normal to the mirror at the pole. Let us understand the important term related to turns of the mirrors actively. What is given? You can give in the figure in the figure 10.2. Both he has given concave and convex mirror. So how the images are formed here? So how the lights will be formed? One is in concave. You can see the focal length, curvature, the principal axis, and everything here. The principal focus is represented by the letter F. The distance between the pole and principal focus of a spherical mirror is the focal length and is represented by the letter F. So these are the things which we have studied already here. So now you will study one by one each other now. So generally you have to remember the image formed by the river of curvature is found to be equal to the twice of its focal length. We put this as R equals to 2F. curvature equals to twice the focal length here. So image formation by spherical method. So how the image is formed in spherical mirrors he has given. So the nature, position and relative size of the image is found by them. However, the image is found by spherical mirrors. How can we locate the image formed by concave mirror for different positions of the object? Are the images real or virtual? Are they enlarged, dimensioned or have the same size? We shall explore through an activity. So he is given an activity here. By taking that activity, we will see what the conditions he has given. So he has given the table here. So you go through this table. The table is 10.1. Image formation by a concave mirror for different position of the object. So how the image is formed in concave mirror of the different types of the object he has given. If the image is the position of the object is at infinity. Infinity means where we cannot see the object there. And position of the image at the focus F. And here is heavily given what is the size of the image, highly dimensioned, and it will be point sized. Nature of the image it will be real and inverted. Means the image we can see the real image, but the main thing is the image will be inverted. See, if you go to, I think many of you have been to Hampi there. If you go to Hampi, you can see these type of miracles there in olden days also. If you go to Hampi inside the Refraction temple, we have one more small hole there. From that hole we can see exactly the tower of the main tower is reflected totally upside down. Inverted image of the tower can be seen there in Hampi. So how it is formed? This is formed. Where is the focal length there? At that time only they came to know how these things are working on the nature of the images formed. It is spherical mirrors are there. But they are not using any mirror there. We have a small hole there. Where through the hole the total image is inverted in Hampi. It is the best example. If you go and see there, you can see the shadow of the tower there, where the shadow of the tower is totally inverted. Inverted in the sense, it is totally up and down. This is there. And he has given representation of images found by spherical mirror using ray diagrams. So generally ray diagrams will be asked here. So when you come to the classes, I will show you exactly how they are formed there, because it will be a little difficult here to show you. So how the representation of images are formed by spherical mirrors. The intersection at least two reflected rays give the position of the image of the point. Any two of the following rays can be considered for the location of the image. So any two rays. So we will not take all the rays here because we have many rays. So we will take only two rays here. So a ray is parallel to the principal axis. First one is it is parallel to the principal axis. After reflection will pass through the principal focus in case of a concave mirror, or appear to diverge from the principal focus in case of convex mirror. This is illustrated in the figure he has given. So go through the figures there, how the focal length, how the principal focal length, how the image is formed after reflection in each of the spherical mirrors, whether they are concave mirrors or convex mirrors. First one, area passing through the principal focus, and a ray passing to the center of curvature of the spherical mirror, and a ray incident obliquely to the principal axis, exactly where the principal axis it is formed there. So you can get different kinds of figures here. So how they are formed, how the principal axis is there. The prompted here. So if you go through the textbook, you will get a clear picture, or once you go through the notes which are given there. So there you have explained very technically how the total images are formed there. But here he has given in the position, but we cannot do practically here. Just you have to imagine it. Practically we cannot see how the images are formed. It is difficult to show practically. But here, according to textbook, how the image is found when they are at different types of positions is given. Image formation by a concave mirror. So how the image is formed by a concave mirror is given. He has given picture. They are very, very important one. Ray diagrams for the image formation by a concave mirror. He has given 1, 2, 3, 4, 5, 6 images is given. You may get in the exam, write the ray diagram of the image formed in a concave mirror. So what will be the focal length? What will be the curved surface in the sense at infinity. First one is infinity, what will be the position there, and use of concave mirrors he has given there. Concave mirrors are usually in torches. So they are used in torches, street searchlights and vehicle headlights to get powerful parallel beams of light. Why? Because you should get powerful parallel beams. So they are used in concave generally. They are often used on shaving mirrors to see a large image of the face. The dentist use concave mirrors to see large images of the teeth of patients. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. So generally these type of things will be used in concave mirrors in this chapter. It means the formation of concave mirror, formation of images, how the images are formed here. I told you already. We are dealing only with the reflection here. So this is how the images are formed here, and what are the uses and what are the benefits of the concave mirror, where they are used, why they are used, and what purpose they are used, because they will be straight and parallel in concave. So that can be used for different purposes also. So this is a very important one. So you may get the question what the concave mirror are used, what are the uses, and you may ask the ray diagram also. So be perfect with the ray diagrams and go through the notes which has been given and which has been sent in Telegram, so that you will be get a clear picture there, so that you can follow what is given already in that thing. Okay, we will move to the next part. Image formation by a convex mirror. Now we studied about what is image formed by a concave mirror, how the images are formed from one to another one. Now we will go with the convex mirror. I told you convex means this is the convex and this is concave, the formation of convex mirror. How the images will be formed? I told you one is diverging, another one is converging. In the lenses, if you go for lenses, concave lenses is diverging lenses, convex is converging lenses. We use these type of two lenses here we use. So he has given the table here, same position, same type of table he has mentioned here. Position of the object at infinity, how the object will be formed, at what place it will be formed, and how much it will be formed and where it is formed he has given there. And between infinity and the pole P of the mirror he has given, how the image is virtual and erect. This is the formation of the image you have given there. He has given the activities also. So I told you activities cannot be done here, but for time being you take it as them. So uses of convex mirrors. So where we use the convex mirrors? Convex mirrors are commonly used as rear wave wing mirrors to vehicles. So if you in the vehicles, if you have the two-wheelers or four-wheelers, whatever it is, the mirrors which we have, those are all convex mirrors. These mirrors are fitted on the sides of the vehicle, enabling the driver to see traffic behind him, her to facilitate safe driving. Convex mirrors are preferred because they are always given erect, though dimensioned image. Also they have wide field of view as they are curved outwards. Thus convex mirrors enable the driver to view much larger area than would be possible for the plane mirrors. So sign convention of reflection of a spherical mirror. This he has given there. Take 1 by V plus 1 by Sir? Sir. So he has given the figure there, 1 by V plus 1 by U equals to 1 by F. If it is possible, I will show you through pictures also how the image is formed. I will explain through pictures if it is possible, if you get the pictures also. Formal length is F and image formed is V and object is U here. So object on the left he has given the new Cartesian sign convention for spherical mirrors he has given there, but for this you remember this formula. Then you go for magnification. What do you mean by generally magnification? Magnification means magnifying, becoming big here. Magnification produced by spherical mirrors gives the relative extent to which the image of an object is magnified with respect to the object size. It is expressed as the ratio of length of the image to the height of the object. It is usually represented by the letter M. So M equals to, that is H dash by H. This you remember. So if you won't get here, so if you won't get there, back into the pass.